Well, what has he got today? Somebody's asked some explicit details about the Team Euro 3100, but there's the Jesan 88900, and we've got a very high quality circuit diagram, and this is all of the EU version. So your circuitry around the phase lock loop has got a conversion board. Has that gone into focus? No, it hasn't. No, it's not going to go into focus at that in that position. I'm not going to move the radio, but we can see well enough that you've got the phase lock loop chip, and then there would be a converter board which is in the radio, and this is an official and legal conversion. We'll put the camera back to its normal position. Hey presto, it's all back in focus. Now, I did this Jesan 88900 before. We can, by the way, we can do this. It'd work out at £3.99 plus post, which would be £5.99. So I can do that information for people. Just have to email me. So, I bought this rather sorry looking one. It's got no front bezel. It's got no meter. And I bought this as a spares and repairs, believe it or not, for £45 about 10 years ago. And I paid that high amount because I hadn't got one and I hadn't seen one and so on. Well, before this even arrived, another one turned up for about the same kind of money, and it was a better candidate. So our Jesan 88900 previous video is based on the better one, and this just kind of got put to one side. So because somebody wants to look at these again, that's where your selective calling socket goes. Oh, it's got their September 97. Fantastic. So there's a selective calling option, and we've shown those cell call units before, which plug in there. External S meter, which is handy when somebody's nicked it. An external speaker, which means we can connect it to the test gear. Now, I don't know whether this is going to be repairable or what. The front bezel is broken. It doesn't have any screws in it, and I've never been in it. That's going to go through the dishwasher. So, let's have a look. So, as I was saying, looking at the circuit diagram, you've got the phase lock loop chip down there, which is a Motorola MC145106, and then it has a official ROM there to alter its programming for 2781. So I'll be taking a black and white photo. The power supply uses a Samsung 723, and I won't be changing the capacitors in that because this is, I know it's 24 years old now, but I've had it 10 years, so I don't think it's been thrashed. It's probably been messed with, killed, and then robbed. You know, this is par for the course. And what my customer, my inquirer, has asked is about components under this shield plate. So on this occasion we're going to remove that shield plate and see what those components are. So someone's taken out the wiring cable clips, and it's all over the place. And we've got a bundle of wires here why would we have such a big bundle of wires? Is this because they've disconnected the display? There may be nothing I can do with this. So at the moment, because of building work, there's a lot of stuff in storage. So it's not like I can backtrack on some of this. Green, yellow, white, violet. Yeah, green, yellow, white is connected. Violet is connected. Orange, brown and blue, they all go to the display. Because of some obscure reason, that's all been disconnected. I could say you couldn't make it up, could you? You really couldn't. So it's gonna, when it comes on, it's not gonna have a display. I do enjoy watching the American gentleman in California, Shango 66. When he goes into the desert and he finds some 1950s television set, and he does a resurrection and actually basically gets the thing working. And this might be what we end up doing with this. I think we're going to have to take the front off, but I think we'll plug it in first. Before I plug it in, we'll actually check whether I dare plug it in. Have I got a suitable screwdriver on here? I doubt it. I'll probably be going to fetch a bread knife. Yeah, I went to tune an organ when I was doing my apprenticeship in Sussex, that was it. And we called for the keys for this church. And there were two ladies putting a plug on a toaster with a bread knife. So it's come out of the cord grip. It actually wants redoing this and dressing better. And it's the earth that's not there. So that needs to be up in the cord grip. But these wires are too long. You know what? I'll do that here and now. Anyway, they're trying to put this plug on this toaster. And I said, I've got some tools with me. You know, we're here to tune the organ. I'll help you if you like. No, we're determined to do it. Oh, right. And tuned the organ 90 minutes later, took the key back. And these two ladies were still putting the plug on this toaster with a bread knife. I didn't offer a second time. Anyway, at least it's got the 3-amp fuse. So we've got a pair of President Randy 3s for optimization. He uses UK channels only, and he doesn't want the power turning up because he doesn't want the power consumption to increase, which is fair enough. That's why a lot of these, shall we say, bigger 40 channel hand portables are in the 2.5 watt to 3.5 watt region, and that includes the big realistics, because the power consumption goes ridiculous. You can probably do 3 point something watts on 750 milliamps, but then when you go to the 4 watts, it might be 1.2 amps. So the battery consumption for the extra 50 yards range just is not worth it, and that's why that is kind of an agreed on figure. I mean, we did that handheld yesterday. It was 2.9 watts or something. It made no difference to the way Mr. Chippy was receiving us. Mr. Mega Chippy, isn't it now? Mr. Mega Chippy. So yes, I can understand that. Right, so that's made the plug safe. We do pat test these things. This is probably slightly short mains lead, and it's about an inch less than I could do with. Well, it's come straight on. The board's loose. Dear. I'm going to have to make up a mic for this. But at the moment, we've got a flickering LED there. You've got this variable transmit power, which is interesting. One day the yellow Aldi multimeter will find its way back instead of the green little one. One day I'll wind you all up and use an Avo 8. So how does it do this? $14.19. I'll tell you what, I think we will turn it to 13.8. It's these short prods that are the letdown on this. There's nowhere to kind of latch it. So assuming this is an adjustable power supply, no, it's not. Okay. So it must be set by a Zener. Anyway, it's within the limits we can allow. So we've got bridge rate, got a transformer, which has a single pole switch, and I've got bridge rectifier. It's got a primary fuse, it's got a secondary fuse, and then we've got the 723, which is amplified by 2SD890. I'm wondering how that is set. So it must be set just through a resistor capacitor network. And if we wanted to know how that is, of course we could look up the UA723 or the LM723 or whatever 723. We can look that up and we can see how they come to get that regulation. So it's not a mystery at all. It's the data sheet's out there. So we'll assume that's okay, and no doubt when it's on load that will drop. Okay, we'll take it from there. So I'll put the little multimeter away. And I think the first thing we need to do is to make up a microphone for this. And that will be fun. I think we'll do that on video. This is going to be a very long video and probably end up with the set not working. Right, I've got myself a blank mic. I've got myself a 6-pin plug. So if we look it up as a team, there's only the 404 mentioned, which is the 4-pin plug. If we look it up as a Jesan, there is the 2002, 4004, 5005, 7007 mentioned, and it's pin out number 1. So it ain't in that list. So it's back to the square kit diagram. And interestingly enough, that shows a 4-pin connector. And it's 6-pin on these. Shows a 4-pin connector on the chassis. Shows detailed wiring of the cell core socket. Okay. Looks like fun time then, doesn't it? I'll do some internet research. So I found this, and that, if it works, will also be included anybody who wants our Squirkit diagram pack. So your other pins which aren't used it will be for use, no doubt, with an up-down mic. I expect that's what it's about. So we've got a bit of sleeving. Don't forget the back boot. These plugs have a further bit of sleeving as an insulator for the soldering. Does our jig have 6-pin on it? I don't think I've used a 6-pin one on this jig before. I think there's only the Shogun that I know has 5. So we need to tin the pins. So have it the same way on as my diagram. I'll just bring this camera down a bit. I can't think that we're quite... Because you'd rather not see my fat tummy, that's probably it. And have they numbered these right? They have. 1, 2... Yeah, they are numbered correctly on the diagram there. So... that's that one tinned, that's that one, and I really can't be bothered to research which is up down for the mic. Personally, it's the last thing I would want. So A is audio, so in these mics the yellow one is the one covered by the screen, and so that is audio. R is going to be receive, which on these mics is black. T is transmit, which on these mics is red. And then C is common, which is the shield. It's nice to put some sleeving on those, and on this bench there isn't any sleeving today, so it's for me anyway. So that bit of sleeving covers the soldering. Shall I put this plug on before trying it, or shall I try it before putting the plug on? Because you know what's going to happen. If I put it all together, it'll be wrong, won't it? So we'll put it all together and then I'll go for a lunch break. this afternoon it's going to be organ, and then we'll come back to this in the evening. These are not easy to tune because these radios need you to have a marker oscillator or a second signal generator, because it's a multiple crystal phase lock loop arrangement, a bit like those those dreadful Icom sets, which are nothing to do with the Icom communications company. It's just a fake name. They may as well have said Gucci on them. And the other I'm thinking of is JWRM2, which is the same kind of thing. So they have these multi-crystal synthesizers, which are DNT as well, which are a bit of a swine to set up. So, all done nicely. So that can go in our little pack of paper. Let's put the camera back in its normal position. And we'll plug this mic in and we'll switch this wireless on. Does it think about going into transmit? Of course it doesn't. Something's happening. I can hear something happening. Might have to put some extra wires on it. I say I might not be able to get any further than this. This might be as far as we can do. But at least we've wired the mic and we've shown a bit about the quite reasonable power supply. So I'm going to put on a signal generator. Because with no channel display, theoretically I ought to press the channel 9 switch, and there we go, 2779125. I'll go to picture in picture. I'll go to transmit, and when I press transmit nothing happens. So I've now got a lot of receive on. And there's nothing coming through, and they've got no squelch, no nothing. So just in case the speaker's open circuit, we'll plug that in. I can now hear a bit of a mains hum. Which is the volume control. First one, let's poke my fingers onto the hot. So I think it's time to take the front off this, and that's going to be fun because you've got to unsolder the back of the microphone connector. It might be unsoldered already, and that's why it doesn't work. So pause the video, I'm going for a lunch break, we'll take that front off. Okay, so I've done a bit of work, like 90 minutes of work, and I've put all the wiring back on this board here, the one which you can't quite see, and as you can hear we actually have some volume. So, no channels. I'll kind of push the board forward. There are no channels. One or two things light up, but no channels. It does go into transmit, I've had to dig out another microphone because the one I've wired doesn't work with it. And this is off another one of these sets. But I'm more bothered about why the thing isn't lighting up a display. So I've blown up this part of the circuit. So we've got 2764 EEPROM. Then it goes to YS32 controller, which is on the front panel. And that is powered by its own 5-volt voltage regulator. Now, what could be wrong? Well, the 2764 could have erased itself, and the YS32 controller could be corrupted or faulty. But first of all, have we got 5 volts? And is that Zener there to protect in case that goes high? I don't know. We'll find out. So I'm going to look for the 7805. And I'm guessing it's actually a 78L05, which is the 100 milliamp version. I'm going to switch this off because it's a bit precarious like this. It could be duff capacitors, as simple as that. See if we've got a layout and we can see whether... Well, it doesn't have a part number, does it, that? It doesn't. No, Mr. 21, it doesn't. So we don't have a layout of the front panel. So there should be, according to the diagram, you've got 1, 2, 3, 4 transistors and a voltage regulator. So one, two, three, 4 transistor looking devices. You know what? I wonder what should be there. Is there a missing part? There's really not much leeway on this wiring. Anyway, I'll look further into it. Okay, I've actually found the problem. There's no earth to the front panel. And the reason there's no earth to the front panel is there is a wire which is snipped off just down there. I don't know if we can zoom in on that. Let's see if we can see my pointer. It's just behind that wiring. You've got a fixing screw where the front would go. And just there, this wire, which is, let's just see whether we get that into shot. This wire, which is to the can of the coil there, goes to the meter, which is missing. And from the meter, it goes to the board, and that's how it gets its earth. So what we'll do, we'll solder that wire instead to the board. So everything, all the voltages are floating. So it doesn't matter where you put your meter, it reads 9 point something volts. It doesn't matter whether you put it to positive, to negative, or anything. So I know that it was floating and there's no earth, and that's why it has its knickers in a twist. So without flexing anything, we just need to solder that wire in place of that one which is now defunct, because he's never going to get a meter, is it? Unless we find an even more beat up one of these. So what has somebody done to this? No, stay there. Okay, so now we'll turn it on, but I'll make sure the volume's lower. Yep, there we go. And it's come on. Let's put the camera back to normal. Squelch working. Right. So I'm going to tip it all up, and you can now see, probably, that it says 9 on the display. I can't see the monitor. Now then, can we move it? Can we move the channel? Yes. So we've got channel 20. So the other question is, do the night lights work? Yes. Right. We're cooking on gas. Well, we would if we had a gas here. So, with the borrowed mic, we'll key it up, because now the phase lock loop's running. Oh, have we got any receive? That's a good question, isn't it? Let's put a suitable frequency on. I think we're going to do this as a two-part because, yes, I can hear it, because the tune-up's quite complex on these. There we go. And that's 1 microvolt. Let's put picture in picture on. Oh, picture in picture is on. It didn't need to have been on. I'll show you the display. Now we'll show the cyanide meter. So what we got for 12 dB cyanide, well, at the moment it's 0.85 microvolts. So there's no wrong with that. Just turn the volume down a bit more. We'll go through all the tuning and that in another video. I just want to show, I've taken this cover off the PA. And let's see when we've now got transmit. Wow, we have. So, it's doing 3.6 watts, which is probably par for the course. And we've got audio, Wallow. We've got transmitted audio, it's about 1.8 Wallow. So, we can now hear ourselves, hopefully, on our monitor receiver. Testing 1, 2, testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Excellent. We need to look into why the microphone I've prepared is wrong. So we'll do that and find out what the problem is, and we will wind up the video there. Now I'm not going to be able to publish the part 2 of this for a few days. I've had to order, all the self-tapping screws are missing. And I don't have any self-tapping screws. I've actually ordered some, so they'll come in a couple of days. But you know what? We've got a working set. Now I know I paid a lot of money for it, and I think this was in a far worse state than I was led to believe. I know it says spares and repairs, but I knew the meter was missing. But I thought, hey, the meter's missing, not all this wiring detached, and that's really taken some time. So there we go. But I've got to the bottom of it. So we'll plug in the mic I prepared. Now you don't need a mic for it to receive because it uses a relay switching system. I'll just have to compare what's different between this and the other mic. So I'll get back to you. Right, I've got to the bottom of it. It was entirely my fault. So, audio, which was yellow on my mic, receive, which was black on my mic, transmit, which is red on my mic, and common, which is the braid. And what I'd gone and done is I'd put the yellow on correctly, I'd put the black on correctly on receive, and then I'd gone and put the red one on top of that, so it did absolutely nothing. So I popped it off, put it on there, and that's it. Well, while I got the other microphone with the cover off, I found out that pin 4 is down and pin 6 is up. Now that is of no interest to me, but it might be of interest to somebody. Now, conclude this part of this video. I've taken that lid off. Let's have a look. Let's take picture in picture off. So I'm not sure what's being wanted to look at. Something about resistors. So we've got resistor 120 there. So the output device is 2SC2078. Resistor 120 is 2.7 ohms. 2.7 ohms. So that's one you could kill with the highest WR. And resistor 122, which is on the base of the driver, looks to be either 10 or 18 ohms. I just can't quite see from the circuit. Unless now I blow up. Not quite. To be honest, I can't think of anything else which would get destroyed. So resistor 122, which I say is either 10 or 18. To be honest, I don't think it'd make that much difference if we got that wrong. And this is the UK version, so it does have all this ROM thing. I thought perhaps it was the foreign version, and it isn't. So 122, I think it's more likely to be 10. So 122 is where? Your driver transistor is what? It looks to be transistor 23. Oh yeah, 2SC 2314. 2SC 2314 is the driver transistor, and so if we can just find resistor 122, so 122 is, there's the can, there's the transistor, and it's in between. And let's just see if we can see what the colours are. No, it could be 8, it could be grey, that. Yeah, let's say it's 18 ohms. Okay, so that's where we are with it. There'll be a part 2 in a few days' time, hopefully before Friday, and that's when we'll do the tune-up if the screws have come. I just cannot tune it up with it all waggling around like it is doing. Just put the camera back to 1, and then you can see this is just all parted, and you know, it needs to be right, doesn't it? I'm just going to end up shorting something out. And the other scary thing is you've got the main switch just here. So although it's got some shrouding on it, it's easy for that to migrate away from the terminals. But that has actually come out better than I thought. I genuinely thought that we were going to be using this as a scrap set, and I'm very pleased that we've got something for the 45 quid, because it was looking pretty scary even to me. So yeah, I can see we're going to get this fully working, but without a meter or the front lens. The front lens should look like that. In actual fact, I might photocopy that, and I don't know, we could probably do something or other. Perhaps Radio Cruncher would could do an overlay, I don't know, but we could get some perspex. With a meter, we're never going to be able to replace that. So thanks for watching the Jesan 88900 extensive repair from having been butchered, and it's part one of 2 parts. We'll do the tune-up probably Friday. Thanks for watching.